My dad's the same. I have to be actually really, really sick to sit.
And if I stayed home, like I couldn't play with my neighbor friends. Like if I was too sick to go to school, then I was too sick to play.
Exactly.
Yeah.
My dad actually, he sends me to school with when I was younger, he was doing with a fever. Hey, even 100, that's not really a fever. You're fine.
Well, when I was going through my stuff, I had 100 fever for days, and they're like, "Yeah, we're not worried about that." It's like I'm worried about everything. So.
As you should be.
Yeah.
100 fevers. It feels horrible when you just stay with 4 days. Your body's just so weak.
Yeah. I was having fevers and chills and stuff too. So.
Does he have a word today?
There hasn't been used for a while, so
Zoe should be here. I think Mason said he would not be here. Blake said he would be here. Will, Oliver. Well, maybe we did have some people. Calvin's not here.
Thank you. I
Calvin.
already have that one.
Calvin's absent.
You're subjective. Thank you.
Okay, good morning guys. So I would like your 10.13 work as I told you on Wednesday. That's where we went over it another time, and I said that would be the one thing I took up today to make sure you had that where it was finished if you wanted the full homework points. So I need that. We've got our short mini quiz that I'll start passing out to you. And then today's focus will be the last of the assignments, and it was actually the first assignment that I missed with you when I was sick. So I will give a quick little brief review of what that's about and how to process with that, and then I will give you guys a chance to ask some of the questions that you tried and struggled with to make sure that that is all checked off as well.
How'd your appointment go?
Well, they took out my drain,
That's good. Hey.
so
Oh, nice.
I feel much more normal. It was nice to shower today, not one-handed at a time, because usually I have to hold it. Because if you let it fall, it kind of yanks and hurts. So maybe in a few days I will feel normal again. But I was able to sleep. I like to sleep on my sides, and lately I can sleep on my left side or my back, and that's been my only two options for weeks. So last night sleeping on my right side was very enjoyable. There's, those little things you just don't appreciate until you can't do them for a while, and then you realize. Okay, I know you're behind.
I think this is what
Okay, we'll figure it out. Yeah. So I think you're missing a couple mini quizzes. I think this is our second one we've done. So I talked about all those in the class recordings. So make sure you glance at those over the break so you know what you need to get cut up when you come back.
Would you like me to take the mini quiz today?
Do you know what it's over?
5. I'm not.
Well, 10.15. That's the typo. I basically told them what 4 of the 5 points were going to be. So if you don't know what those were, then I would not do it today.
I won't do it.
Because it's not meant to hurt you. It's meant to just try to give you some points to make sure you're doing some of the stuff. Okay, so as you guys start here, this is supposed to be, I numbered this one for you. This is number 70. As promised, it was 5 points. 2 of the points come from the memorization parts for questions 1 through 4. So if you memorize what I suggested or asked you to, those should be gimmies. Now, I'm going to even give you one more hint here. If you remember what I asked you to memorize in 10.14, this is a different form of that. So whatever you get for question 1, if you want to plug in n is 0 to see what the first term would be, and then n is 1 for the first term or second term, and n is 2 for the third term, and n is 4 for the fourth term, it should be what you memorized for me on the last mini quiz. So that would help you check your work a little bit. The 5th question is a question straight from the homework. So I tried to pick out 2 that I thought were similar difficulty for the different forms. And then number 6 is an AP question. That's the only one I didn't give you a hint on what it would be, but it is multiple choice, and of course, same topic. So go ahead, put in your best effort there, please. And then as you finish and turn that in, if you would find your 10.12 assignment, it was on Lagrange error bounds, and we'll talk about that together and make sure that at least by the end of the period you feel okay with that. And kind of lucky, but that's kind of a good stopping point for spring break anyway. So. Over here. So ideally I would like you to take your homework back today, but instead of passing it back, I'm going to finish it. Some of you have a couple other old assignments. So at some point today, if you just find the one with your name on them and take them all back, I would appreciate it. Thank you. Okay.
Pass out the test, or?
Yeah. Well, not test. It's just the short course.
Yep.
Was unable to find sensical work that goes with this. Got a bunch of nonsensical stuff, but I don't think it even relates to this assignment.
Okay.
So I'll turn it in as is,
Okay.
which is only not great. It's like the first. I didn't do the rest
Okay,
of it.
why don't you, well, you've been absent, so why don't you finish it and I'll still give you full points. You need
Thank
to
you.
finish it for practice anyway.
Yeah. Where do I use this? I'll take. Bless you. So, I shouldn't go for or yeah, you can. I think I got it. This was the one. Still yeah, so now it'd be it's
Okay, I think everyone's done. So again, if y'all would please get out your 10.12, even if you felt great about it, because I just want to talk generally, kind of what's the point of what that section's about, what's the formula you kind of have to know and how to deal with, look at maybe a couple questions together, and then help you with some that you tried, and then just in case it's something you struggled with while I was gone, you'll have the class period to feel like you get caught up on that. And then coming back from spring break, we should all be kind of back at the same place. So. Okay, so part of this one is, this is called Lagrange error bound. I'm assuming there's a mathematician, Lagrange, that came up with this. But it's kind of unfortunate because the name doesn't give you a hint on what this is about. But basically, I guess the error bound says a little bit. So what we're trying to do is we're trying to figure out how wrong or how much of an error some of our Taylor polynomial approximations are. So Taylor series was, I think, 10.10 or 10.11. It was one of the last ones I was here for you on. But just very generally, a Taylor polynomial is an estimate. It's where you can take a function like e to the x, and then we can estimate it, and the more terms we have, the closer we get to actually being equal to this term. But the general idea is whatever the function is you're trying to approximate, you want to make sure it's at the right point. So I'm just going to say I'm centered at 0 to make it easy. So this would be the point. And when we did this, I said go ahead and say x to the 0 divided by 0 factorial. I know those are both 1, but if you include that as part of your formula, it makes it a lot easier to memorize. So that makes sure it starts off basically at the right y-intercept, the correct point, but then to make sure it has the correct slope there, we would find the derivative at that value, the first derivative, x to the first, over 1 factorial. Now again, I know 1 factorial is 1, but you get to see first derivative, x to the first, 1 factorial. And that makes sure it has the right slope at the value it's centered at. And then to make sure it's even more accurate, we make sure it has the right concavity. So second derivative, where we center it, or I'm sorry, at the x value, and x to the second over 2 factorial. And again, if you, even though this and this and this, these three things are kind of unnecessary to memorize for the formula, if you practice doing it this way, then it's easy to say, all right, the next one is to the third, 3 factorial, etc. So to the n derivative, x to the n over n factorial. Just makes it a lot easier. But that's what the Taylor series was about. Taylor series is a way to approximate and change a function to a polynomial. So Lagrange error bounds is about how incorrect is that. So it kind of depends on how many terms you do. If you only make sure it's at the right point, it's going to be pretty incorrect. If you go all the way out to the fifth derivative, and you make sure it has the right point and the right slope and the right concavity and the right jerk and the right fourth derivative and the right fifth derivative, it's going to be pretty accurate. So that's what Lagrange error bound is about. Us trying to measure how much error there is, and or figure out how many values of n we have to go out to make sure the error is below a certain number. So basically, this gives you kind of a good idea. I mean, it's just a real simple formula here, but this gives you an idea of what you're doing. The exact value, which is usually referred to as the function, is equal to the approximate. So the exact value would be like the real function, e to the x or something. The approximate value would be the Taylor, I'll just say, this would be like a fourth derivative Taylor polynomial. Actually, I'm going to do third, because then I can say that would be this much of it. And that's not, these two things aren't equal, because you've got to do plus the next term, plus the next term, plus the next term, plus the next term. Basically forever, it needs to go to infinity for them to be equal. So how wrong is it? Is this, the plus the remainder. So that's kind of the big picture. Now, that doesn't have too much to do with answering the questions, but it kind of helps you see where the remainder is coming from. Now, the formula that you have to memorize, oh, they did the same thing right here. I should have looked ahead a little bit better. But the real function is equal to the Taylor approximation, which is pretty close. It's closer the further you go out, but it's always going to be a little bit off. The stuff that you don't do is considered the remainder. Okay, so the formula that you will have to memorize for this, also, I know this is kind of a sidestep here, but I would like you to have 10.12 finished after class today, because you're going to have a chunk of time to ask questions, get help, and just retry stuff. But because of spring break, when we come back, I will not have a mini quiz for you the day we come back, and I'm not going to ask you to turn in an assignment the day we come back, just because we're coming back from break. But I will continue with the mini quizzes, because again, it forces you to do just a little bit of effort, and those 5 major points start adding up pretty quick. So I know sometimes they can seem annoying because it forces you to be a little more consistent, but I do think it's good for you and good for your grades. So that's why I do that, because it does take me a while to make them and print them and grade them and pass them back to you and stuff. So anyway, I hope you see that as a good opportunity. Okay, so anyway, eventually we'll have a mini quiz, and the thing I will ask you to tell me that you have memorized is how to find this Lagrange error bound. So the absolute value of the remainder will always be less than or equal to the absolute value. And now notice this n here. So if I want to know the remainder for like a 4th degree Taylor polynomial, then n is 4. That's going to be the max, and this might be where you had the most questions, because this is kind of unusual for a formula. The max that the n plus 1 derivative could be, and sometimes we use the letter z there just to not mix it up with x. So basically, if this is a 4th degree, this would be like take the 5th derivative, the next derivative, and the biggest that it could possibly be for that context of the question. So if the 5th derivative is cosine, what's the biggest cosine can be? So you'd put a 1 there. If it's sine, same things. The biggest sine ever can be is 1. You think about the unit circle, and as it goes around, maxes out at 1. So this is it's kind of weird, again, as far as the formula goes, but typically it's not too hard to find. They can't give you something extremely crazy there because then it's too hard to work with. Okay, times x minus c, where c is the number we're centering it around, and x is the value we're trying to find the error at, to the n plus 1. So again, if we're trying to find the error of a third degree Taylor polynomial, this should be x minus c to the 4th, divided by n plus 1 factorial. So, I don't know. Maybe I just pick one of these out. As an example here. Okay, I don't know. Let's just look at the first of the practice questions. Again, we don't have to look at anything too hard at first, but it gives us an example of what to work with. Okay, so the third Maclaurin polynomial, so there's a lot of information right there. Maclaurin tells me it's centered at what?
0.
Okay. And because it's the third Maclaurin polynomial, that means n is going to be 3. Okay, for sine, so we're going to deal with sine, is this. So they did the little power series, which makes more sense to you now that you look back at that. You should kind of understand where that's coming from. If this third degree Taylor polynomial is used to approximate sine of 0.1, what is the Lagrange error bound? So basically, how wrong is it going to be if you only do this to a third degree? So based on the formula I said that you would need to have memorized, we could say the absolute value of the error, and n is 3, that's why there should be a little 3 there, is less than or equal to the absolute value of the max of the what derivative? Fourth, good. This is n equals 3, this is n plus 1, so the fourth derivative. And again, I'm just going to use z just to make sure it doesn't get confused with x, times, and then we had x minus c to the n plus 1. What's the n plus 1? Okay, and down here this was n plus 1 factorial. So again, if you understand third polynomial, n is 3. So over here it's n plus 1, n plus 1, n plus 1. So that's why those are 4. Okay, and then here you need to be a little careful with the signs. In this case it's to the 4th degree, so it doesn't really matter. But this is supposed to be x minus c. In this case, we know c is 0. What is x in this question?
0.1.
Very good. So the value they plugged in the sign is the x value. Okay, so some of this is going to be pretty easy to work with, I think. 0.1 minus 0 is 0.1. 0.1 to the 4th power. I don't know. A 10th times a 10th would be 100 times a 10th would be 1,000th times a 10th would be 1/10,000th, I think. We're going to use a calculator in a second anyway. Over 4 factorial, which again is just 4 times 3 times 2 times 1, so I can do that, but I'm going to use the calculator in a second anyway. The part that you kind of have to slow down on, especially since this is to the 4th, this isn't to the 4th power, this is a general way to say the 4th derivative. I could put 4 tick marks there, but as you start getting high derivatives, you don't want to put 6 tick marks for a 6th derivative because then you might not be able to count them correctly. So what was the function that we were trying to do this for? Very good. It's sine. So over to the side. Again, it's never going to be anything too terrible, but The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And then the fourth degree, which is what we need, would be what? Sine. And they start looping, right? So even if this was like the 20th degree, you see how you could just start counting? First degree, or first derivative, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. So you could actually find the 20th derivative, not too bad, since they start looping. Okay, but this, again, this is the part that's kind of weird for a formula. I want to know what's the max that that could be. So how big can sine get to be? So that's why that's a 1 right there. And so this is where our answer should come from. So in my calculator, well, I could actually probably give a pretty good fractional answer here, but 0.1 to the 4th divided by 4 factorial. Here's what the calculator says. It says 4.16666666667 e to the negative 6. So they're not going to write it like this on a multiple choice. What does this e to the negative 6 mean? Right, so this is like you're moving the decimal 6 places to the right. So as a decimal answer, I would move it once to put it in front of the 4, and then the next 5 times would create zeros. So the answer could look like this as a decimal, or it might be like 4.16 repeating times 10 to the negative 6. They could make it look either way. So kind of similar to what we did in 10.13 in that there is a process, but most questions are very much kind of following the same pattern here. So once you do that process 3 or 4 times and you kind of get over what this max means and you actually try it a few times and you see the number's not too hard to come up with. But I think for me, probably the biggest connection you need to make to be successful here is you need to understand some of these numbers and how it compares to this. Third Maclaurin polynomial means n is 3, which means this was a 4th derivative because it was n plus 1. It means this is to the 4th power because it was n plus 1, and this is 4 factorial because it's n plus 1. So 3 here means you've got a bunch of 4s over there. If this was 6, these would need to be 7s. So that kind of quick glance. Okay, so I know that's just a general overview, but I know it didn't hurt you because even if you did great with this lesson, it was, I don't know, 2 or 3 weeks at this point. So I guess if you see, let's try to stick to some of the early questions first, just because usually they have less tricks to them and we can worry more about foundational stuff. So on the next page has questions 2, 3, 4, and 5. Do any of those look like they would be better to discuss than the others?
You do 3.
Sure, we can do 3. So let's do 3 together here. Make sure that you remember it, even if you got it right, and then I'll open it up and let you guys ask in case you got stuck way further in the assignment. Okay. All right, so in question 3, we want to know the air bound to approximate E. And when it says about 0, does that mean, what is this telling us? Does that mean I should plug in 0 for x at some point?
Center is 0.
Right, the about means, I really like to say that C is 0, because that's where you're centering it around. I think the x equals 0, this kind of throws us off a little bit. Okay, for this guy, well, This is e to the x. This should actually look familiar to you now because you have memorized the power series for e to the x. But notice in this question they reminded you, because that's not what they're testing you on at this point. Okay, so if I want to get the remainder, the absolute value of the remainder, now I guess I need to know what n is supposed to be. How are we supposed to know what they want n to be?
We just,
I was thinking maybe it goes to the 5th degree.
Very good. So notice this e to the x didn't say plus dot dot dot. They showed you where they wanted it to stop. So you kind of have to investigate a little bit here to see that they want n to be 5. So my answer is going to come from the absolute value of the max of the which derivative?
6th.
The 6th derivative, good. And of, I'm going to call this z, so we don't confuse it with the x's, it's not the same thing, times something to the 6th, all divided by 6 factorial. Okay, this is supposed to be x minus c. Now again, this is easy to switch these two up. You've got to be careful. C is what you're centering it about, so that was right here. Less obvious is what is the x value? Very good. How do you know it was 1?
Because of the first term.
Right, so this is the function. Oh, well, also the first term, right. I was actually looking at this. If you're trying to approximate e and the function's e to the x, then x must be 1.
Oh, yeah.
So they're telling you x is 1, they're just not saying it in words, but there is enough information to see that. Okay, so our answer is going to come from, well, 1 minus 0 to the 6 is just 1. 6 factorial, I don't know. I'll let my calculator worry about that. And then this is the part that's, again, a little tricky, the one where you really have to practice several of these to feel comfortable with this. But I need to know what the max this function, the 6th derivative, could be at. So, like the last question, I started with the function, took the derivative, took the second derivative, took the third derivative, took the fourth derivative, took the fifth, well, I don't remember how far we went. But in this case, if the function is e to the x, what's the derivative of e to the x? So the second derivative is going to be, so the 6th derivative is going to be, right, so it's not as bad as it seems. Now,
is there times when we'll actually have to solve out all the way to like the 6th derivative? And it won't be like sine or cosine or x.
and it's usually something that's pretty convenient, like e to the x or sine or cosine. Like if they gave you something that was like quotient rule and then you had to do that 6 times,
Yeah.
like I'm sure they would love to see if you could do that, but it's so time consuming it just wouldn't make sense to put it on the AP exam. Okay, now this part, so the max that e to the x could be, well, e to the x goes to infinity, but we really only care about a range of numbers here. It's centered at 0, and we're trying to approximate at 1. So this z that we refer to, I really only want to know what's the max that e to the x could be between 0 to 1.
Just e.
How do we know what, sorry, how do we know what x is in?
How do we know what x is?
Yeah.
Well, I said this. If this is our function, and they're wanting us to approximate e to the, what's the exponent there?
Gotcha. Just over.
Right, so x became 1, so that's how you know it. Or that's how I saw x was 1.
Gotcha.
Liam mentioned that also if you paid attention to the first term here, you can tell. So, okay, so are you guys okay with this 0 to 1? Where I'm centering it to, and then the x value. The z, I really only need the max between these two numbers. So e to the 0 to e to the first. What's the biggest that gets?
E to the first.
E to the first, E.
Right, so the biggest that could be is e to the first. So So our answer comes from e divided by 6 factorial. And again, I guess that could be your answer if they made it multiple choice. No calculator. If they give you a calculator though, you probably need to type in e divided by 6 times 5 times 4 times 3 times 2 times 1. And that give me an answer of 0.0037753914. And just like your Cal AB test, they want you to round to 3 decimal places. Oh, or truncate to 3 decimal places. So I would prefer you to round to 3 decimal places. So again, most of these questions are pretty formulaic. You start with the formula, figure out what n has to be so you can update these numbers in red. Figure out what x and c have to be. They have to tell you that stuff. Like x was a little more hidden in this question, but it's in there somewhere. And then this max part is kind of weird. So the max that the n plus 1 derivative could be between the values of where you're centering it in the x values. Okay. So of course, some of the questions will start to maybe throw a little bit different stuff at you, and some of them may just be harder to interpret. So I did ask you to try this. So do you guys have any questions you remember trying and getting stuck on? Just seemed harder than the rest. I lost my last 2 pages here, but we can still try them together if we need to. Do you have any of those questions ready to go? Otherwise, I'll give you some time to continue to practice it and make sure you look over it. Because this is the last thing we're doing today, so we still got about 50 minutes of class to make sure that you're up to speed here. Okay, let me give you about 10-15 minutes then to either re-practice some of these questions, practice some of them you didn't know how to start, or try to finish some of them that you got stuck on. And then in those 10-15 minutes, after 10 or 15 minutes, I'll ask you for some help again. Yeah.
Could you do number 7 actually?
Sure. Okay, so I'll do number 7, and then I'll start the timer. So if you don't need number 7, you can go ahead and move on to that though. Okay. Boy, this one's a long one. Let f be a polynomial function with non-zero coefficients such that the function is equal to that stuff. T sub 4 is the 4th degree Taylor polynomial for f about x equals c such that t sub 4 is equal to that stuff. Based on the Lagrange error bound, f of x minus t sub 4 must equal which of the following? Okay. I don't really remember this question, but let's go ahead and give it a shot together. Now, first off, so reading through this is kind of wordy. It might be a good idea to read it a couple times. I'm not a great reader, so maybe that's just me. But this is what we're trying to find. If I take the real function and subtract the 4th degree Taylor polynomial, what is this really asking for? Or what does this mean? What does this represent?
Remainder.
Right, and specifically the remainder when n is 4. So if you take the real function and subtract the 4th degree Taylor polynomial, you're trying to figure out how much error it has for that 4th degree. Okay, so that's what we are trying to find. So if I start thinking about the formula here, well, over here, what do we know? If n is 4, we would know that I guess right here, they didn't tell us what x is and they didn't tell us what it's centered about. You can see they're keeping those generic. So this is going to stay x minus c, but to what power should that be? Right, it should be to the fifth, because this is 4. This is supposed to be, this is n. N is 4. This is supposed to be n plus 1, so that's to the fifth. So that's where you can start to see it's got to be choice B, C, or D. Okay, I know from the formula this needs to be 5 factorial, which makes me think that it would be D, but it's actually not D. So I don't know. I didn't write down too much on this. Y'all remember where the 5 factorial goes? Those of you that got this one. Okay, I'll have to pause here for a second, and I didn't write enough work out for me to remember what I did here, so. Oh, okay. I think I remember what happened. Okay, so I think what actually happened here is I can see that I started to write out the formula and I put an X through it. I think the formula just doesn't help us in this question. I think it goes back to this understanding at the very start of the notes. If you take the actual function and subtract the polynomial that you're estimating it to, the remainder is the leftover parts. So if I think of it like that, now this is, I'm not going to write all this out because it's going to make it more confusing, but so the real function is equal to the Taylor approximation at 4 plus the remainder that happens at 4. So if I take all, and think of this as an equation. If I subtract this over, that's how I can find this. So if I take the function, which they're telling me is all of this stuff, and then I subtract this over and subtract all of this stuff. Now remember, if this is a 4th degree Taylor polynomial, it's supposed to be at the right point, so a sub 0 and b sub 0 should be the same value. So you subtract whatever, 5 minus 5 or whatever it is, those cancel out. Then it's supposed to have the correct slope, so those should be the same. And then it's supposed to have the right concavity, so those are supposed to be the same. And then you do the function stuff minus the Taylor polynomial stuff, that's to the 3rd power, because those are like terms, and you get that. And then you take the 4th degree stuff minus the 4th degree stuff, and you get that. And then what's left over is this fifth term of a times x to the 5th. But we might want to center it somewhere else, and then that's where it should be C. So I think the formula actually doesn't help you out too much. You really need to think, at least for this question, the real function equal to the Taylor polynomial plus the remainder. So basically they gave you all of the function, they gave you this, or all of the function up to the first 5 terms, subtract that, and then it leaves behind what the remainder is. And again, the reason I was able to cancel these is because the Taylor polynomial approximation, these are supposed to be the same point. They're supposed to start at the same y-intercept. They're supposed to have the same slope. They're supposed to have the same concavity. So that's why all that stuff, I knew a sub 3 was the same as b sub 3. So if I remember right, I think that's what I eventually did. I probably should have written it down on my paper, but do you have a follow-up to that, or?
I think I'm good.
That's okay.
Why does the formula not work?
Well, the formula might work, but one thing is, if you tried to use the formula, you really need to know what the function is so that you could try to do the fifth derivative of it. And they don't tell you straight up what the function is. I mean, I know they kind of give it to you generally here. But you kind of need to know what this is representing. And I don't know. I don't see that, but I'm not saying it's impossible, but I don't think that that's what they intended for you to do. I think what they intended for you to do is say the real function is equal to the approximate polynomial plus the remainder. Take the real function, subtract the approximation, and then that's how you can find your remainder. And then when you realize this stuff minus that stuff makes everything go away except for this, except it might not be centered at 0 because they never said that in this question. It could be centered at C, and then make that last change. I think that's what they were aiming for, because I think that's more efficient. But if you want to try it with the formula and let me know, I'd love to see when and where you get stuck. But okay, Calvin, did you have another one that you had ready? Not yet. Okay. Okay, let me give you 10-15 minutes here. Again, if nothing else, you can just be scanning your assignment. You could retry some questions. You could try to finish some questions you got stuck on the first time, whatever. Just be moving forward, and then I will bug you to try to help again in about 10 or 15 minutes. So we just do that a few times, and then we should be all okay with this at the end. Yes, Oliver?
Is it the max of the absolute value of the derivative function?
No, it's the max of the n+1 derivative of the function from the x value to the center value. But it's absolute value of the whole remainder, so. Because remainder just means like how far off are you, right? It doesn't make sense, like why would you say your remainder is -2 off? Just say it's 2 off, like that's why there's the absolute value there. I do want to wait to pass back the mini quizzes until everyone has a chance to actually take those, but I did score those and put those in the grade book, so they did look good, so you can at least check that if you were interested in how you did. But again, you'll have to wait till people have a chance to also take it. I only have a couple forms of it, so I don't want those to be out in the wild before everyone takes it. Well, it just defeats the purpose, because then y'all just try to study to the quiz and not to actually put in a couple minutes of work to try to review.
Mr. Townsend?
Yeah.
On number 7, is the fifth derivative not just a sub 5?
Well, wouldn't it be 5 times a sub 5
Oh,
times x to the 4th?
wait,
Wouldn't you have to do the whole
That'd be
power?
the first derivative, right, and the second one would be
oh wait, yeah.
20 a sub 5 x to the third.
Oh, okay, so,
And you-
okay, so the formula does work then?
It does work.
Yeah.
Okay.
It just, I got the derivative wrong, so you should have some like big number that cancels out with the 5 factorial at the bottom
Okay.
for the derivative.
Yeah, I think it'd be 120 a sub 5
Yeah, okay.
to the
Yeah,
x,
then,
right?
Then the 120 cancels out the factorial.
I think so.
How do you know that's going to be 120 though? I guess is my.
I just did
We just keep deriving the function.
5 times 4 times 3 times 2.
Oh my gosh. So you took the function.
I think,
Hold on. I just want to make sure I understand.
I don't know if I did it right.
That's fine. We can figure it out together.
Pretty time consuming.
I mean, they look like easy derivatives at least. Okay, so you took this derivative 5 times?
Yeah.
Okay? I mean, really, if you think about how this is going to work, you could skip a lot of this. But the first derivative, of course, the constant goes away. So then you just get I'm not going to take any shortcuts here, but I think you'll see some pattern where you really could skip a lot of this. Okay, so then the second derivative, now this is a constant, so it goes away. Oh, okay, I guess I'm starting to see where the 120 is going to come from. After you do the derivative 5 times, it's going to create that. That makes sense. Again, I don't know if this is the most efficient way, but it's good to hear that it did work out for you. 20, a to the 5th, x to the 3rd. So the third derivative, constant, 6. Oh, I missed something here, didn't I?
The x should be gone from the 6a.
Gotcha.
Yeah.
All right, there we go. So then this would be 6, a to the 3rd plus 24, a to the 4th, x plus 60, a to the 5th, x squared. You know, if you had seen this before you took calculus, you would have never taken calculus. Okay, derivative, 120, a to the 5th, x. And then finally the 5th derivative. So this goes to 0, so 24 plus 120. A to the 5th.
Wait, the 24 should go away.
Oh, right. This is a.
Yeah.
Oh, this went away because of derivative. Okay, I trust you. All right, so if you did that, I guess then you could see the a to the 5th. You could see that dividing by factorial cancels that. So, I don't know. That sounds okay to me too, but I don't know. Honestly, what I would probably do is practice. What I will do later today, actually, is I'll probably practice both ways separately, just fresh, and then kind of reevaluate which one I think is most efficient. Maybe your way is easier. I'm not sure. Because I mean, it does look messy, but the derivatives are all pretty easy.
Yeah.
So, yeah,
Does A mean something specific, or is it just like a constant?
it's just a generic constant, some number that they're just not telling you what the number is.
So A sub 0 isn't like the 0th term or something?
It's just the first term. It's when you plug in 0 n for n into a sub n, which is, you know, whatever the series would have been if they had given us the series.
Okay.
Yeah, Oliver?
Could I show you a cool formula?
Sure. You want to put it on the board over there so you can leave it up?
Is there a marker somewhere?
Is there not any markers over there?
No.
Here, I've got some over here. Somewhere. Did somebody steal my markers? Oh, the blue box on top of the white box. picked red, I can't see, so.
It's a formula for an derivative.
Okay, that's n over 2 pi, integrate 0 to pi, f of e to the 2 pi plus
E to the IT.
Oh, RT. Of course.
What does it do?
I mean, I believe you, I trust you, but I couldn't prove that, so.
So if you wanted to take the second derivative, you plug in n equals 2.
So you're saying in my AB class, instead of teaching them how to take the derivative twice, I should just show them that?
Yeah.
I mean, it doesn't.
Even though they don't know how to integrate at that point in the year.
Taking the super high derivative.
Sort of. It also lets you take like fractional derivatives.
Well,
So you have to take the real part of the function.
It's interesting.
Like when you take
Take a half
45, how do you take 1.5 derivatives?
It's used in some contexts. It's like
It's like the illogical.
sounds complicated.
But taking e to the e to an imaginary number doesn't really make sense until you learn about Taylor series. Because
Wait,
Taylor,
what?
like in Taylor series, you can have something n equals 0 up to infinity of x to the n over n factorial, which would be, but if you e to the I would be, if you plugged in I, that'd be the sum from n equals 0 up to infinity of, if you, let's say ix, so that'd be I to the n over n factorial. But because this is I to the n, if you plugged in the first term, that would be 0, or sorry, if you plugged in the first term, that would be 1. Then it would be I. Then it would be negative 1 to negative I. But it's split out in there, where it's ordered between 1 and negative 1 and I and negative I. It would be this is the 0th term, the second term,
So what I will add to this is how college usually goes. Oliver's the professor who gets to talk about the fun theory stuff that he wants to talk about. And then you'll have drill class, which is what I'm doing. And I try to help you like figure out how to get the answers right. That's a lot of what college is.
I know, I didn't understand that completely.
I don't have a clue what's going on there.
If you raise I to the different values, you get, like every second term, you get 1 and then negative 1 and then 1 and then negative 1.
I think that makes sense. Okay, yeah, that does make sense.
Yeah.
Because I squared is equal to 1, right?
Yeah, and if you take the n, so like this is when n is 0, this is when n is 1, this is when n is 2, this is when n is 3, and so forth.
Okay, yeah.
So for n equals 0, 2, 4, 6, every second term of the n,
Okay.
it is an integer value that alternates between 1 and negative 1.
Okay.
So you get, so you just take 2n, which is every second value, and you take negative 1 to the n, that gives you the same thing.
Makes sense, yes.
It's making a bit more sense.
Y'all didn't
And then you take, and this is the same alternating between plus and minus, but it's just multiplied by up. So then you just take 2n plus 1, starting at the first term, and then going every second term, and you get 2n plus 1 or 2n plus 1 factorial. Factor out I.
Y'all didn't get questions like this in Algebra 2? Like, what's I to the 67th?
I feel like I did, or like it's an ACT type question maybe.
Yeah, it is ACT.
Yeah, ACT.
It sounded, I think that's what Oliver was talking about for a second. Just like,
Yeah.
there's only a few terms that alternate, so you really only need to know the remainder.
'Cause-
So.
yeah.
Because like
Squared is
I
negative
to the
1,
0
right?
is 1, anything to the 0 is 1. I to the first is I, because anything to that. I squared is good to memorize, but if you know I is square root of negative 1, and then the only other one you have to memorize is this one.
Minus I.
Yeah, because you're just multiplying these two. And then you start repeating. I to the fourth is like multiplying these two, which goes back to being 1. So there's really only 4 values. So if you can figure out how many times does 4 go into 67,
My brain's not working.
40, well 10 would be 40.
40 plus 6.
14 would be 40 plus 16. So wouldn't that be 40 plus 16 is
Wait, it need to be
56, so I could do another 4
I think it would need to be
and another 4.
16, right?
Yeah. So basically, if you want to say 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, you can count up to 67, but basically you're going to cycle through those 63 times, and you're going to have a remainder of,
Yeah, it's 15 and 3/4.
oh sorry, 15.
Yeah.
So 15 would be 40 plus,
Wait, isn't it?
15 times 4 is 60.
10 times 4 is. Oh, yeah.
15
So it'd be
times
16
4
would
is
be
what?
16, right? Because 16 times 4 would be 64.
Yeah, it's got to be 16.
Yeah, so 16 equals.
Is 64?
Yeah.
So basically, you could cycle through this 16 times. Who cares? If you end up with the remainder of 3, it's the same as I to the, oops, it's the same as I to the 3rd, which is, if you just memorize those 4, that's that one.
Yep.
That is an ACT question right there.
Really? They don't put that on your Algebra 2 test? I feel
They
like,
might have. They
It's
probably
just
did.
been- it's
I
just
don't
been
remember.
so long.
Yeah, they probably did.
Freshman year.
okay, let me give you just a couple more minutes here, and then we'll try to round out with a few more questions if I can help some more. We still got about almost 20 minutes here, so is there another question or two I can look at with you? I will be offering the same thing to my 5th period today, so if they ask anything different than y'all, I will record them and add them to the website. So, but is there another one or two we can look at?
Number 6.
Number 6. All right, we've got Taylor series for some function centered about x equals 3. They gave us the series. They tell us it converges from 0 to 5 if we use the 3rd degree Taylor polynomial about x equals 3 to approximate f of 13 force. What is the alternating series bound? Okay, well, let's see. I took this, I believe, and I realized that this was a sub n, and so if a sub n is, well, now when I do remainders, when I do remainders, we really only want absolute value. So I don't really care about this -1 to the end, right? Because that's just what makes it alternating. So the a sub n part is actually just this. Okay, and then for us, we would try to do this. It looks like if we're, where did I come up with that? Oh, okay. What should n be in this question? Or what is, I'm sorry. Yeah, what is n?
3 or 4.
Okay.
It'd be 3.
It's going to be 3 because we're doing a 3rd degree. So n is 3. So the error is going to come from
4.
From the 4th. Now, this seems a little bit out of place. This isn't specific to today's lesson. This is actually alternating series error bound. Remember, that was a totally different lesson. So the part that you have to remember for alternating series error bound is that if you want to know the error of the first 3 terms, it's always less than or equal to the 4th term. If you want to know the error of the first 8 terms, it's always less than or equal to the 9th term. It was always less than the next term. Absolute value. So really, if this is a 3rd degree, I know his error has to be less than the absolute value of the 4th degree. I already did absolute value, took away this part. So when you plug in 4 here, I got the 16/13 times 13 fourths over 3 to the 4th, and I don't know, I wrote that as 13/16 times 1/4 to the 4th, and then I stopped. You okay with how the 13/4 minus 3 became 1/4?
Yeah, that makes sense.
Okay, and then let me double check. I circled that as my answer, so I assumed that was okay. Yeah, you just can't really do much with that arithmetic without a calculator, so they quit there.
Okay.
But if your answers had weird decimals, just throw that in the calculator. And but again, that's not specific to Lagrange error bounds. That's alternating series error bounds, which is just a different process. You want to know the error of the first 5 terms. It will be less than or equal to the absolute value of the 6th term. So just mixing in a review question there. I think I already asked, but is anybody doing anything fun for a break? Any fancy vacations this year, or summer camps, or Silver Dollar City, or?
Or where you been?
We're going to Baton Rouge, New Orleans.
Okay. Have you been there before?
Yes, we usually go down about once a year.
Okay.
I've never spent much time in Baton Rouge, usually just go straight to New Orleans.
What are you gonna do down there?
My mom is sometimes just some scenery.
Just be careful. There's lots of scammers and lots of pickpockets.
That's a big one.
My wife's dad got pickpocketed like 2 or 3 times in New Orleans.
Was it only one trip? Or?
No.
Okay, I was gonna say, that'd be insane.
My dad got pickpocketed down there.
Yeah.
So-
They're very good at it, so.
Yeah. Somebody bumps into you, they're like, oh, sorry. And then they just-
Yeah, somebody else grabs your wallet, or sometimes kids will do it and then the kids run off and like, what are you gonna do, go tackle the kid?
Yeah.
So,
Chase the
Brandon
kid.
would.
I mean, I am a kid, so.
yeah.
Stop the kid, like.
See, I was nervous. We only went one time. I've only been there one time, and my wife has been there a few times, but one time with me. And she has like a purse backpack, you know? And she would put her phone in the side, and her phone's halfway sticking out.
Oh man.
And I'm like, please don't do that. And then so she won't listen to me. And so like I have to like stay behind her the whole time and like
Make sure.
try to watch. But if someone grabbed it and run, I don't know what I would have done anyway, so.
You could beat him up.
No, probably not.
You know, I was in, when I started. doing
Also,
that,
those scams, like they probably run down an alley and they have
other people-
a couple older guys down there in case they need help or something.
Yeah, probably, yeah.
It's not the kids stealing your money; it's the kids that are part of the thing.
Mhm.
So,
I had these pair of pants, and they had not only the back pockets, but it was like a zipper. To zip up the second pocket in the back, and that's where I kept my phone.
yeah.
So,
Do you have any plans? Stay tuned.
Well, my wife doesn't get spring break off, so
Oh.
if I went on vacation without her, it wouldn't. That would not
She'd
be pretty.
jealous.
Yeah. Well, she's already jealous. I'll have time off, so
Mhm.
it would be really bad if I spent a bunch of money to go sit on the beach somewhere. I might get divorced over that. No, usually I just start doing a bunch of house projects. I usually do a garden and stuff. This year I probably won't, just because I've got a late start in my stomach. I don't know that it's fixed yet, so.
Mhm.
But just clean house. Our refrigerator broke recently too, so our house is kind of a mess right now.
Are you gonna get a new one or try to fix it, or is it like you can't really fix it?
Well, I think we got lucky. We bought it like 4 years ago, and so I guess it's under warranty, which I was surprised about because I've never been able to get anything out of a warranty.
Yeah.
But one of the people we called to see if they could fix it asked for it, and so I just like sent over email where it showed that I purchased it and the date and stuff,
Mhm.
and they said they were so confident that that LG would pay for it, and they were so confident they knew what it was that they didn't even come look at the refrigerator until last night, and they just showed up and fixed it. So I think we will. So it's fixed now, and I don't think we'll have to pay anything.
Sweet.
Yeah, that's why my mini fridge is gone. When our refrigerator broke, my wife was like, "You have to bring your mini fridge home," and I was like, "Well, I'm not supposed to lift more than 10 pounds." So she came up here, she got the dolly out of the garage, and we wheeled it down the stairs. And
Down the
Use the
stairs.
elevator.
The elevator's locked.
Oh, whoops.
well, I can get in my elevator.
Oh, wait. Okay.
I didn't think about it, but she was parked right out here, so I only had to go down that one set of stairs.
Oh, man.
That's not so
But I probably set my recovery back a few days. I mean, I still did the majority of the lifting. But I don't know, just food going bad. We haven't been buying much food to eat around the house because we don't have much refrigerator space. There's just a lot of cleanup from that, so.
Yeah. So they took the drain out.
They did. Yep, they took the drain out yesterday.
I thought they said it would be like 10 to 12 days.
They said 10 to 14
Oh.
that one time, but I kept calling them saying like, so they bandage you up after surgery.
Mhm.
I was getting irritated because no one ever looked at it after the surgery, even though I'd been in multiple times. The tape, they use surgical tape. Well, the tape gets real itchy.
Yeah.
Like I've been wearing it for weeks, so I'm like itching and like I'm trying to like peel it away a little bit to scratch
Yeah.
And then finally I called them up one day and I'm like, can I please take this off and rebandage it or come in and rebandage it? And they're like, oh yeah, you can do that. Okay, why didn't you tell me? So I did that, and then when I did that night, I noticed, I had a hole in my stomach
Yeah.
for the drain, and like around it was kind of white, like a little pussy, and I was worried that I was infected,
Uh-huh.
and also because no one's looked at it.
Yeah.
And I have this spot above where the drain was that's hard. It's almost like there's a grape in my belly. It's like soft to the left and soft to the right, so I was concerned.
Yeah.
So I was calling and telling them all this because I started oversharing because so much has gone wrong. I just want.
Yeah.
And so they're like, come in today. And I was like, well, I'm at work. And they're like, can you come in this afternoon? I'm at work.
Yeah.
So they're like, will you please take pictures of it? So I took pictures and they said, okay, you need to come in. So I came in Tuesday for them to look at it. And then they set me up another CT scan for yesterday. And I guess it was good enough. So, I don't know.
What hospital did you go to? Or like,
It's Washington Regional.
Washington Regional. Okay.
Yeah. I told that's where my wife works. And I said, well, if anything else ever happens, I guess I'm going to a different hospital just because
Yeah.
I've been so unlucky. And she said, the other ones are actually even worse. So.
I'm surprised because you said they didn't even tell you that you had to like flush out the drain and stuff, right? And then
Well, here's the problem. So I got my appendix taken out.
yeah.
If they had just put a drain in me from the beginning, this wouldn't have been a problem. But they don't do that because most people don't have complications.
Okay.
Most people just feel fine after 2 days.
Wow.
So they didn't do that because it didn't happen to most people. And then I got my drain in me, and usually if you have a drain in you, you just need it a couple days and it pumps it out. Most people, it doesn't block it. So
Yeah.
that's why they didn't tell me how to unblock it, because it doesn't happen to most people. So at some point I told them, I was like, I'm tired of being the exception. Y'all need to tell me what you want me to do now and what you want me to do at the next step so I can be prepared.
Yeah.
But yeah, that's why I keep saying, if y'all ever need your appendix out, don't like let my experience scare you, because it doesn't happen like that for most people.
Yeah, I think Daxton's sister had her appendix removed like
And it was fine, yeah.
when she was like 8 or something.
Yeah, my dad had his taken out, and he said he was playing golf like 2 or 3 days later. So
Wow.
I just got unlucky with the complication and
Mm-hmm.
unlucky with the pump being blocked, and so.
Are you feeling better now? Like, or is it still kind of uncomfortable?
Honestly, since I've been back to school, my pain tolerance is just so weird right now, because like I haven't felt great since I've been back. Like I'm tired and like usually pretty sore,
Mm-hmm.
but I just feel a million times better than I did when my belly was full of blood.
Yeah.
Like that was pure agony. Like I was in the hospital basically screaming at them for a
Wow.
while.
That sucks.
Yeah. Then my wife told them to give me something, so they gave me an Ativan, and I should have. But just in comparison, like I've been happy just because of how good I felt, but I haven't felt 100%. So, it's like you
Yeah.
get a cold and it's awful for a few days, and then you're almost recovered, and like you don't really feel good that last day, but like you feel so much better than you did that you're
Yeah.
still.
Yeah, I know that feeling. Like when you have
Yeah.
a stomach bug and you're like throwing up and you just feel terrible, and then you're just like, if I felt normal, I would feel amazing.
Yeah.
It's like,
Gives you some perspective for sure. Did I tell you how I figured out I needed my appendix out?
Yeah, stomach pain.
No, I threw up all night one night,
Yeah.
couldn't sleep, and then at some point in the night I realized my stomach hurt. But my body, the way my body told me was just to throw up constantly. And then the next morning, until they gave me pain medicine, or they gave me something to settle my stomach, I just constantly throw up. I drink a sip of water and then I'd throw it up.
Wow. Did your appendix like burst or what?
It didn't burst, no.
It just got inflamed, or like how does it happen? You know?
I don't think they know how it. I mean, like it can get like backed up a little bit, or
Uh-huh.
something can get in there and make it get infected.
Mm-hmm.
But I don't think they know why that happens.
They just-
But they also don't know like that the appendix really does very
You
much.
don't really need it, right? Or what does it do?
I think it might help you with like some of your like white blood cell count or something, like
Okay.
your immunity a little bit. But it's kind of like your tonsils. You're fine without them.
Yeah.
So.
What I've always heard is just a vestigial structure, so from evolution at some point it had a purpose,
Oh.
and now it doesn't.
Okay.
But, I don't know.
So I'm more advanced now that I don't have it.
You're evolved.
That's what I heard. See, I have my tonsils still too, and I feel like I get lots of sore throats. I kind of wish I had gotten mine taken out as a kid, but they say you're not supposed to do that anymore, just because it's an unnecessary surgery, and surgery sometimes has complications. So,
Just don't feel like it's worth it.
yeah, unless you need it. So.
Mhm.
No, but a lot of it recently has just been the drain. Like sometimes I'll do something and like my drain drops, and you know, like when it drops, it pulls on me a little bit. Yeah,
That drain comes.
yeah. And showering with one hand at a time while I hold it is not fun. And sleeping, I would sleep in shorts so like I could keep it in my pocket. But then like I was paranoid about laying on it because like
Yeah.
if I'm squishing it, it's not able to like, I don't know, it's just
Yeah.
a lot of little annoying things. But
Yeah.
actually the worst was when I took the bandage off. It had some like, you know, gooey, pussy a little bit.
Mhm.
Well, that had stuck to my stitch, which was a string, and to my bandage, and I didn't realize this at the time. So anytime my bandage moved, it was basically like tugging at my most sensitive part of my stomach.
Oh my goodness.
Yeah, so it felt like a knife was in me sometimes for that reason. But once I figured that out and like I kind of separated them,
Yeah.
then it was fine. So,
Well,
but it would have been nice if someone had told me. Like I feel like I'm an expert on it now. Like I feel like the hospital needs to consult me. I feel like I know more about it than they do.